So suppose you just had a child, and your parents, as a gift to the child, open up an account with $1,000 in it for when they turn 18 years old, right? We're going to see how much that's going to be worth after those 18 years. So let's suppose they put it in what's called an index fund, which is basically broadly intended to match where the market is, usually based off S&P 500. I don't want to get into the technical details, but it tends to be, because it's somewhat formulaic, very low account fees because they're kind of sticking to formulas that are having all these advisors figure out how to invest money. It's just following whatever the market does. Well, over long periods of time, these returns have tended to be close to 10%, again, over a long period of time. Over short term, like stock markets all over the place. But over long periods of time, it tends to average out to be about 10%. Okay, so that's what we have set up here, is just some index fund account in the amount of $1,000. What is going to be worth when that child turns 18 years old and can access that money? Okay, well, that means our principal, P0, is $1,000. Our annual rate of return, this is just going to be an estimate, is going to be 10%, which we write as its decimal form 0.10. Our T is the number of years, right? So that'll be 18. Right? Wait until they turn 18 years old and can access that account. Now I just need to do the calculation. So our book uses A for the future value, or the amount in the future, I guess is what that A is for. And that's going to be our principal times 1 plus R to the T, right? This is going to be compounded, right? As if we're investing it into an account that's based off stock market, right, we're earning that 10% off the 10% that we already got in the last period, right? So we're constantly getting that reinvestment compounding. Okay, so this principal will be our 1,000. And it'll be 1 plus this R written as a percent. So 1 plus 0.1. And then I want to raise that to the 18th power. Of course, don't forget, we always do the parentheses first. So that's going to be $1,000 times 1.1 to the 18th power. All right, so when I do that, it comes out to be $5,559.92 rounded to the nearest cent. Okay. So we got a more than 5 times return on our investment, okay? Or more than 5 times back off our investment. So that's pretty good. Let's think about if we didn't even tell that child they had that account. Only told them about it when they retired. Okay, let's change it to that. So now, suppose the child retires at 65 years old. How much is that $1,000 going to be worth when they retire at 65? Okay, well, it's the same formula. I'm starting with the same principal of $1,000. I'm getting the same interest rate of 0.1%, again, over long periods of time with this. And my T here is the only thing that changes. It's now going to be over 65 years. Okay. So when I do that and I get 1,000 times 1.1 to the 65th power, I get $490,000 and 370.73. So basically that $1,000 investment comes out to be $500,000. Not bad, right? Definitely not bad. the idea here is really that this compounding, because of its exponential growth, I'm going off the camera here, but because of that exponential growth, we're seeing just massive returns over those longer periods of time, right? Because we're allowing that compounding to really have its effect here. All right, so you see how this calculation's done? It's really just plugging in 3 numbers into the formula. I want you to be mindful of the fact of how we need to do things. So theoretically, if you're using a scientific calculator, it should have, right? So if you put in to a regular calculator 1,000 times 1.1, right? And then this like little up or whatever your button is to make it raise it to a power of 65. It might just do this part first, right? But we know we need to do the exponent first, right? That's what our PEMDAS, our order of operations, is telling us. Your scientific calculator should know that order of operations for you. That's actually part of me saying you need to get one for this course, is that it will do that for you. So just remember to put this inside part in parentheses, right? We don't want 0.1 to the 65th. We want 1.1 to the 65th power. So just be mindful of your order of operations. Otherwise, this is really just plugging in 3 numbers into the formula and getting that into our calculator.